In this example, we're going to find the average rate of change. So we have to just remember the average rate of change formula. What does that mean? Well, we're going to find an average rate of change over an interval. So that means we definitely need some more information, which is given here, a and b. So we're going to find the average rate of change of this function over the intervals specified here. So let's first talk about the average rate of change. That's just the change in the function, so change in f over the change in x. So this would be f of x equals the natural log of x. So just evaluate some function for some interval and divide it by that interval. So that's the average rate of change formula. So first thing that we'll do, and it doesn't really matter which way you subtract. I usually do the second one and then the first one. It doesn't matter which way you do it as long as you do it the same order in the top and the bottom. Just like the slope formula, y2 minus y1, you could do y1 minus y2 as long as in the bottom you do x1 minus x2. So you just got to keep it consistent. So here, the average rate of change for part A, this would be the natural log of 4 minus the natural log of 1. And we could use our log rules for that, but I'm just going to put it in my calculator. And then I have 4 minus 1. I'm keeping the same order. 4 first? Okay, 4 first has to be down there. Alright, so 4 natural log, that's 1.386 and something else. I'm keeping it in my calculator. Minus, and then the natural log of 1, which is 0, of course. I didn't remember that. And then 4 minus 1, that's 3. So I'll just write down 3. So I have this stuff, and I'm dividing it by 3. So I'm doing that in my calculator as well. Divide by 3. So the average rate of change of the natural log of x from 1 to 4 is 0.462. I didn't round here. I left it all in my calculator. I rounded to 3 decimal places here. So the average rate of change is that. And if we looked at the graph for the natural log, this would be 1, and it crosses through that. Oh, sweet. Nailed it. First try. So I'm going from 1 all the way up to 4. 1, 2, 3, 4, something like that. And, right? 1, 2, 3, 4. Yes. So the average rate of change is just this slope. It's a slope of the secant line. So, and that's what that means. And then for part B, same idea. Yeah, I'm not going to do part B. I'll talk about it in the graph. It should be, so this, it's relatively small. Like I mean, I suppose I exaggerated it when I drew the graph, but here, the slope is even smaller because it's less slanted. So when you do this stuff, actually, I'll do it. We would have the natural log of 103 minus the natural log of 100 divided by, what is that, 3? 103 minus 3? No, what? 103 minus 100 is 3. And so I'm going to plug this in. So 103, take the natural log, subtract, that's like 4 point something. 4.6347 and such, minus 100 natural log equals, that was like 4.06 something. So that, and then I'm dividing by 3, so then that's part B, sorry. I don't need that equal sign. And then what would that be? That would be 0.029 something, I think. And I still have to divide it by 3. Divide by 3. And that gives me 0.00985 and such. So, yes, this slope is definitely smaller. That means it's way, way, way less slanted, almost approaching the slope of 0, but it never gets there, so it'll just go on and on upwards forever. Slower and slower, but upwards forever. All right, I'm done with this example.